Hello and welcome to Thermochemistry. It's for your TI-84 plus CE calculator or TI-84 plus CE Python. And we're going to go over these 13, not 13, I think it's like 5 problems here. I think I might get one wrong, so forgive me. Okay, first one, if 1,643.4 calories of heat are added to 50.430 grams of water, initially at a temperature of 10.759 degrees Celsius. What's the final temperature of the water? So what we're going to do is go to heat transfer because we're adding heat to something. And then we're going to go to temp heat capacity. That's option 3. And then we're going to choose. Now, I know a lot of you guys are going to be doing joules, but there's also a calorie option for this. So I'm going to go calories here. And then so for Q, for the calories added is going to be 1643.4. Sorry, I'm 1643.4. And then for the mass in grams is going to be 50.43. You can just put 0.43 or 0.430. Either way is cool. Now, this is the standard heat capacity of water is 1. And then I think there's like something in STP conditions I have if you don't know what that is, but that's cool. And the temperature initial I think is 10.759. And then it looks like 43 point, okay, so let's just write this down, 43.3467. I think we go 3 decimal places. That'll then become 43.347 degrees Celsius. How much heat is required to melt 200.12 grams of ice at 0 degrees Celsius into water at 0 degrees Celsius? The latent heat of fusion of water is L sub F is 80 calories per gram. So what we're going to do is go to the main menu of the thermochemistry, and then we're going to go to phase changes. And then we're just melting ice here. So we've got a few options here. Melting ice, vaporizing water, and complete change, meaning going from ice to water vapor. So we're going to choose melting ice, which is option 1. And then we're going to go to calories. And it shows the latent heat of fusion, 80 calories per gram versus 334 joules per gram. So we're going to go option 1 for calories. And then we're going to do the mass, which is, it's asking us the mass in grams. It's usually in grams. If it's in another unit, I'll make another iteration of this program. So just, comment on that if you'd like to see something else. And then it looks like it's 16,009.6. And if we're just going to units here, because it looks like we're only going units, nothing to the right of the decimal. So I'm going to go 16,010 calories for question 10. Okay, great. We are going to go to phase changes, option 3. And then of this, we're going to go to complete change because we are going to be going from ice to steam. So that's complete change there. And then we're going to choose option 1 for calories. Good. And then what we're going to do is the mass is 500.73. And then it takes, oh my gosh, that's a ton. 300. Okay, this is definitely not 0 in the units place, even if I round. So I'm just going to round it to 360,530 calories. This is the one I think I'm wrong because I went through a test of this and I'm like, man, I think I got it wrong. Okay, so for number 12, a hot plate is used to transfer 401.51 calories of heat to a beaker containing an ice-water mixture. 505.32 joules of work is also done on the ice-water mixture by stirring. What is the increase in internal energy of the ice-water mixture? How much ice melts in the process? So there's actually a few things we have to do here, and not just answer the 2-part question. The big thing is they mix calories and joules. So first thing we want to do is, because we want the answer in joules, we want to convert this calories here, and I'll underline that in red. We want to convert this calories, the 401.51 calories, into joules. So what we have to do, we go to internal energy. We're going to be staying in the internal energy for this one. We have to convert calories to joules, because remember, it wants the first answer in joules. So we want to say, okay, how many joules is that red thing? not the answer, but the red thing underlined. Sorry about that. So we're going to do calories to joules, and we're going to do 401.51. There we go. And so that's 1680.72086 joules. Okay. And then we're going to add this 505.32 joules. So what we're going to do, we're going to, and then du, meaning the change in u, is q plus w. And then we're going to be in option 2 for joules. And then for the q, that was the 1680 because that's the hot plate transferring the heat there. So 1680.72. This is officially doing it using the calculator program. We could also do it, by hand like I just did. So if you're bored, just skip ahead a minute. And then the work done on it is a 505.32. So we get a total of that 2186. Okay, 0.0. So it's going to be 2186.0 joules for the first thing. And then I'll go blue for the next one. What is the increase? How much ice melts in the process? So for this one, we go to ice melted, option 4. Okay. And then we're going to go option 2 because we're going to talk about joule inputs here. And then this is where I wrote it down, the 2186. So 2186 point, and I'm just going to go, all the decimal places there just to be safe. And it looks like we've got 6.5450 grams. Okay, great. Finally, a problem done. Okay, now number 13. We're going to go back to the main menu. Excuse me. So 504.29 calories of heat is added to a gas. The gas expands, doing 505.66 joules of work on its surrounding. What is the change in internal energy of the gas? So this is going to go to option 4, internal energy again. And then now the answer is in joules, so we're going to be doing that, right? But what we have to do is there's the calories added to the gas, and then doing work on 505.6. So the first thing is we've got to go to the unit conversion here. Okay, so that's going to be option 3. And then we want to go to joules, right? So we got to do this, so it's not confusing. I'll make the joules already in red. And so we're going to be converting the blue to the red, the 504.29 calories. So we're going to do option 1, calories to joules. So the calories is 504.29. And that's 2110.9574. And then the gas expands, doing 505.66 joules in the surrounding. Now, what happens is that means the heat energy that's added to it, some of it's dissipated from the from the gas. So what happens is that is going to be a negative value for the work done. So let me explain this. We're going to do the du equals q plus w, the change in u, the delta u equals q plus w. So, and again, we're going to be doing this in joules here, so option 2. And then the q, right, that's going to be the amount added. And I'm just going to round it up to 2111 in joules. And then the work, now this is what's funky. Because the gas expands doing work on its surroundings, that's going out from the gas to the surroundings. So it's negative 505.66. Okay, and we get 1605.34 joules. I think the only one in decimal place. So we're going to do 1605.3 joules. Oh my goodness, there it is. That's just a sample of what you can do with this thermochemistry program. If there are things you'd like to see added to it, please make it in the comments. Like it if you like it. Don't like it if you don't like it. Subscribe if you want to see more stuff. And then if you get this program, again, free updates for life. Okay, peace. May you do well in your thermochemistry questions.